Hello and welcome back to the lab. Well, I've done it again. I bought another eBay instrument. This time it's the HP 412A DC vacuum tube voltmeter to add to my collection, after restoration, of course. This is a DC only voltmeter. It measures DC volts, DC milliamps, and it also measures ohms. It can do volts from 1 millivolt up to 1,000 volts DC. Milliamps from 1 microamp up to I believe 100 milliamps. Maybe it goes up to 1,000 milliamps, 1 amp. It also measures ohms from 1 ohm center scale to 100 megohms center scale. The meter movement is a beautiful, large, and easy to read mirrored scale movement with volts and milliamps ranges on the top of the screen and ohms at the bottom. The ohms ranges are logarithmic. Looks like 4 decades of logarithmic displays with a 1 in the center scale. So the center scale on the ohms is equal to the range. So it can measure 1 ohm center scale up to 100 megohms center scale, which means it can really measure greater than 5 gigohms of resistance with this ohm meter. The probes on this instrument came with it, and this is the DC volt probe. It's got a probe tip that can open up, become a grabber tip. Very nice. There's the common alligator clip, and the ohms and milliamps lead is the red wire. It also has an alligator clip. Now, all 3 of these cables are shielded cable, coaxial cable. Um, this is a floating voltmeter. Unlike the AC voltmeters that I've been working on, this one, the low lead, the common lead, is not grounded. It's actually shielded by a grounded cable. Um, the center of that shielded cable becomes the common low terminal connected to the alligator clip. So this voltmeter can make floating measurements um, up to 500 volts DC above or below ground. So this is a floating voltmeter, not like the AC voltmeters I've been working on. It's a tube-based voltmeter, of course, hence the name vacuum tube voltmeter. So there's only tubes inside. This one appears to have been made in 1961 or thereabouts, a little bit after perhaps. That's from the serial number on the back panel. So on the front panel, we have, of course, the large meter movement itself. We have a power on switch and a power indicator lamp. We have the 3 input cables, which are permanently wired into the front of the panel of the instrument. I'm not really crazy about that, but it does have many advantages. A couple of disadvantages too make it more difficult to store because you have to store it with the test leads. The test leads do not disconnect from this front panel of this voltmeter, but it allows you to have safer connections, and it also allows you to have coaxial connections with shielded cables coming out of the front panel, which you wouldn't have with ordinary test leads. Also, there is I believe it's a 1 megohm resistor inside of the probe of the DC volts probe to isolate some of the capacitance in the cable from your circuit under test. That's what the 1 megohm in here is actually for, which you would not have in an ordinary test lead. So that's why they're permanently connected, so that you can't make that mistake. The function switch is over here on a lever, volts, milliamps, and ohms. It seems to be working fine. The range switch, of course, the rotary switch in the center of the instrument. That seems to turn freely. I'll bet it's not in good condition inside. We'll find out. There's also a polarity reversal switch. You can switch from positive to negative volts so that you don't have to swap your test leads from one polarity to the other. You just use this front panel switch. So let's take a look at the rear panel. On the rear panel, we have an ohms adjustment pot and a bias adjustment pot. They are um, secured with a locking nut once you make those adjustments. There's a DC amplifier output. This instrument is also can be used as a DC amplifier. So that output is here, and it is also floating unless you connect the load to the ground terminal. Power input. Power cable is permanently wired into the back of the instrument. Power cable is not in very good shape. I may end up replacing that as well. Serial number tag, prefix 124, that indicates that it's made on or a little bit after 1961. So this instrument is almost as old as I am. Almost. Okay, and it also has a fuse holder, the line fuse on the back panel. So before I plug it in and turn it on, I like to do two things. One thing is to make sure that the line voltage is set to the correct line voltage. It's selectable either 115 or 230 volts, and it is set to 115. So that's correct. That's good. And I also like to check the fuse. I know in this instrument it's supposed to be a half amp flow blow fuse. Let me see what it says. Doesn't look like a half amp. This is a 3 amp flow blow fuse. That is not the correct fuse. There's no way this instrument's going to draw 3 amps of current, not even close. So that's the incorrect fuse. So I don't dare plug it in and turn it on because someone has changed the fuse, which means there might be a reason why they have changed the fuse with the incorrect fuse, like there's a short internally to the instrument or something. And we don't want to release any unnecessary smoke before testing this instrument out. So I'm not going to just plug it in and turn it on. So we're going to have to open it up and take a look at the inside to see if I can find any shorts or anything like that. Take a look at the condition of it. The condition externally, it seems to be in pretty good shape. It's very dirty, of course. The leather handle is completely missing, and I have a solution for that as well, and we'll get to that later. Externally, it just needs a lot of cleaning up. Other than that, it's probably in good shape. Internally, we're about to find out. So let's open it up and take a look inside. But before I open it up, I wanted to do the safety warning for this instrument. It's a tube instrument, and that means there are high voltages inside, sometimes lethal voltages, and sometimes even when the instrument is unplugged and turned off, there could be capacitors that are charged up to lethal voltages. So if you're not familiar with working with tube type equipment, please refer the servicing to someone who is qualified to work on this type of equipment, because you don't really want this to be the very last voltmeter that you ever get to work on. Okay? All right, so to open up this instrument, we remove the 2 Phillips screws on the rear panel like this. There's one. And there's 2. And then it should just pull out. The front of the instrument should pull out of the rear frame of the instrument like such. And the line cord feeds through back. Yeah, that line cord is not in very good shape. I will probably have to replace this, but I can use it the way it is for now. Let's take a look on the inside. A couple of things I see right away. Those bumblebee style caps that everybody likes to talk about, I'd be willing to bet they're probably just fine, actually. We'll make some measurements of those capacitors to see if they are fine. but something might be causing a problem because we have the wrong fuse inside this instrument. We've got a big electrolytic can here. I'll test that to see if there's any leakage or shorts or anything in that. So we got some voltage regulator tubes, OA2, um, OB2. Those are both voltage regulator tubes. Those cold cathode gas discharge tubes, like tube style Zener diodes. That's what those really are. We have a 6X4. I think that I'm not sure what that's for, but we have a 6X4. We have is that a 12AX7? It's big for that. I don't know what that tube is. I think the 12AX7 is this one. Yeah, this tube is the 12AX7. The tube is here underneath the shield. One of my favorite things about this voltmeter, it actually has a motor in it as part of its circuitry. Um, this motor spins when the instrument is on. It's one of the few motorized voltmeters I've ever seen. Um, this motor is part of the chopper assembly to convert the DC voltage into AC voltage, such that an AC amplifier can be used to amplify the DC voltage and turn it into an AC voltage, and then demodulate that same AC waveform to turn it back into DC once it's amplified. Um, Later instruments used flashing neon lights instead of a motor with a rotating disc. You can see the little disc on the side over here, and it does freely rotate. So I bet that motor is probably just fine, but I haven't turned it on yet. We have another multi-section electrolytic can capacitor over here. Um, we have it looks like maybe a 5-watt power resistor that was heating up quite a bit and got a little burn mark on the side of the power transformer. I don't know how well you can see that on the camera. Um, Maybe this is what was drawing too much current, or maybe it's possibly normal. I will check all those things out before plugging it in and turning it on. Definitely take a look at the multi-section capacitor. Make sure that it's not shorted. You can see this switch is pretty pretty corroded. I will end up cleaning all the switch contacts in this instrument with some sort of electronic contact cleaner. All right, so let me take a look at some of the components and make sure they're okay before going any further. All right, let's take a quick look at the schematic of, of this instrument. We have the input comes in over here, goes into the modulator. Now this is a pair of photoresistors that chops up our DC input voltage and converts it into a square wave, which is AC coupled through a capacitor into an amplifier here. The 12AX7 amplifier section. There is also a 6AU8 amplifier, pair of amplifiers over here. After that square wave AC signal is amplified, it is demodulated with this demodulator, which is another pair of photoresistors that are synchronized to the first pair, such that you can track the peak of the square wave and convert it back into DC volts. This demodulator is actually operated by that motor we talked about. The motor is down here, and this motor spins a disc with a hole perforated into it, and that hole allows light bulbs to shine onto the modulator and demodulator photoresistors in such a way as to make them convert the DC at the input into an AC square wave and then back into DC at the output. That DC drives another cathode follower, which provides voltage to drive the meter movement itself. We have the DC power supply down here. Rectifier circuit. Here's our unregulated B plus voltage. Doesn't say what that voltage is. It's going to be probably something in the neighborhood of 350 volts or something like that, I suppose. We go through a dropping resistor into a pair of gas discharge voltage regulator tubes, an OB2 and an OA2. The OA2 provides plus 150 volts DC constant voltage across it, and then on top of that we have an OB2 which provides an additional 105 volts. So 255 volts DC should be up here. We also have a Zener diode from what is normally the low of the circuit to ground, so that the Zener diode will actually drop 6 to 7 volts. So you have a negative 6 or 7 volts over here. So what I'm going to do is I will check these voltages, plus 255, plus 150, and negative 6 to 7 volts. If I have those three voltages, then I know that this power supply circuit is working properly. We'll also look to see if the motor is spinning, and we'll look to see if those lamps that illuminate the modulator and demodulator are illuminated. We also have the front panel power on indicator lamp here as well. So it's 5 lamps. I believe they're all the same light bulb. And we'll make sure, of course, that all the filaments and all the tubes light up. And we'll find out why they had the incorrect fuse in here. So first thing is to put the half amp slow blow fuse in where the fuse circuit is, and then we'll just plug it in and turn it on. I'll attach my voltmeter to these points and see what the voltages read. And if there's something off there, I'll shut it off immediately. All right, so I had to remove this inner shield by removing the three screws that were attached over here, so that I could get access to the bottom of this capacitor, and to put my voltmeter on the negative 6 to 7 volt DC power supply. And that's attached here. I've also attached a short between the ground and the low terminals to make it easier to make my measurements. I didn't really have to do that, but this way the internal chassis is grounded to the outer chassis and to earth ground, making everything a little bit safer, I suppose, plus easier to make the measurements. On the other side, we have my 255 volt measurement is over here, and my 150 volt measurement is over here. These are all connected to different voltmeters, and I guess we're ready to turn it on. Oh, I replaced the fuse with the correct 1/2 amp slow blow fuse. I don't know what's going to happen. Oh, I also did take a look at measuring the capacitors, and I didn't see any that were shorted. I didn't see any that were leaky either, but I don't know for sure. But I didn't see any shorts, so I imagine we should be good to go. So let me turn it on. All right. No indication on the front panel, but that probably means that light bulb is burnt out. The motor is spinning. I don't know if you can see it on the camera, but the motor is spinning. That means there is voltage on the DC motor. It's an AC motor, by the way. There's voltage on the AC motor. 6.3 volts it should be, right? None of the light bulbs are illuminated. We probably have 4 burnt out light bulbs, because they should all be lit up, as well as the front panel light bulb. We have 5 burnt out light bulbs, but we didn't blow the fuse because the motor is spinning. Now let's take a look at the voltages we have here. Oh, we do have voltage. The 250 volt supply measures 255. The 150 volt supply measures 150. and the negative 67 measures negative 6.7. Wow, very good. We have voltages. We don't have any lights. Perhaps the only thing wrong with this instrument is a bunch of burnt out light bulbs. I believe I have replacements for those light bulbs. Let's drop them in. All right, let me turn it off first and unplug it. Let's put in some new light bulbs and see if maybe it works. Okay, so these are the light bulbs I pulled out of the 412A. All four of them measure open, and I measure it with my ohm meter. I do have replacements. If you look very closely, the two pins on the replacement bulb are very, very slightly longer than the two pins on the original bulb, and those will not fit properly into the sockets. So I'll simply take a pair of diagonal cutters and snip them off to make them the same length, and they should drop right in, and hopefully we will have an instrument that starts working. Let's find out. All right, so the new bulbs are installed, and I'm ready to turn it on. Let's see what happens. The bulbs light up. Very good. That's a good start. I wonder if the voltmeter is working. Now we have meter movement. We are on the DC volts 1 volt range. Let me set it up with some voltage on the input and see if it responds. All right. Well, with the unit put back together, sort of, and enough to test it anyway, and with power supply connected to the DC volts probe and the common terminal, it's set to the 1 volt range. Let's apply 1 volt to it and see what we get. Oh, well, the meter certainly responds. In fact, it's reading off the scale. It's reading quite a bit high. Let's switch it up to the 3 volt range and take a look at it. Oh yeah, on the 3 volt range, it's reading about 10% high. It reads 1.10 volts. Wow. On the 10 volt range, it is reading about 15% high, 1.15 volts, something like that. So this is probably just an adjustment. Let me go through the realignment procedure and we can get this thing going. It's really very dirty inside. So what I thought I would do is really clean all the dust and dirt out of the inside. I have to clean all the switch contacts for every range. I also have not gotten the power indicator light on the front panel to work. I'm going to work on that. I will probably end up replacing the line cord and getting the the probes as cleaned up as I possibly can. I also do have a replacement leather handle for the top. It's not a replacement leather handle, it's the whole case with an original leather handle still attached, that I bought just an extra rear case for this instrument. So I will put that on and we'll have a leather handle. So let me get going on doing all of those things, and I'll be back when all of those steps are completed. Okay, so I spent about an hour cleaning the inside and the outside. It was really quite dirty. Um, and did replace the line cord with a brand new one and realigned everything. And it turns out that that measurement error that we saw was indeed just a adjustment. Um, so, put it all back together and we have a completed instrument. Here we see it measuring 1K ohm precision resistor, and it measures spot on. So that will do it for the HP 412A DC vacuum tube voltmeter. Can't wait to add this one to my collection. Thanks for watching. Please like and subscribe, and stay tuned for more videos of vintage test equipment and other fun stuff. Thanks again.